Hi, Matt. Thank you for joining us today. We're very excited for you to speak about GitHub and Git technology. Everyone, thank you again for attending. We're going to have Matt introduce himself, and then we'll get started with the presentation.
Thank you, Sarah. Hello, everyone. I'm Matt. I'm a computer science graduate student, and I'm finishing up my master's degree. I'm also an employee at the University of Chicago Center for Translational Data Science, where I work as titles research programmer. I also am a graduate assistant for CDM. So, yeah, and in addition to my coursework, so kind of busy. I am going to teach you guys some of the basics about Git and Git technology, and the famous website, GitHub. So I'm sure you guys are very curious about that particular part of it. So it's all based on the Git technology, though. So that's what I'm going to cover at the beginning of my presentation. And then we'll move on to a demo, which I'll show you about GitHub and the website and how to interface with it and how to use that in addition to your local. We'll learn about this, the difference between like a local repository and a remote repository. So with that, I'll go ahead and share my screen so you guys can see my slides. Let's see. Okay. Okay, so should be sharing my screen now. If I'm not, let me know, but I will go ahead and start this. Okay. So hopefully everyone can see my PowerPoint slides. And if not, like I said, just let me know. So the presentation here is on Git and GitHub. So I'll just start with a little introduction. So version control systems, that's kind of the category of technology that we're talking about here. They're used to track changes from files over time. And these version control systems allow you to revert back to previous iterations of the files. You're never going to need to name your projects final, really final again. So we've probably had instances where you want to save different versions and then just name them different things. And so with Git, you don't really need to do that anymore. You can back up your copies onto a remote server, which is what will be known as like your remote repository. And that's what GitHub basically functioned as. So that's useful because obviously if you have a problem with your computer and it crashes or you lose changes for some other reason, that copy will still be available on GitHub in this case. So Git, it's a distributed version control system, so as opposed to a centralized one. That means every developer's computer stores the entire history of all the old versions of your project. We call the entire history of a project a repository. So the fact that a repository is stored locally means that we can use Git on our computers without any internet connection. So here are a few commands that you're going to use a lot with your local repository. And the first one here is git init, and that's just to make a repository. So it's going to transform the folder that you're in, the directory, into a Git repository. And what that does underneath the hood is just basically adds some like dot files. There's like these hidden files that'll add and kind of lets Git know that this is a repository and does some things we won't really talk about in this presentation, but because you don't really need to worry about it, at least not to use it, in the basic sense. So the next command here is git add. And so that's going to add a file that you made changes to into what's called the staging area. We'll show a little bit more what that means and how to use that in our demo. Git commit. So that takes all the files that are in the staging area and permanently adds them into the project's history. So it's kind of like permanently, what I like to think about is like it kind of puts it into your memory. It's like your long-term memory. So once you do git commit, all the files that were in the staging area gets committed to memory. And git status is just a function or a command that you can use to see what the status is of all the different files in your repository. So some of them might be in staging, some of them might not be, some of them might not be tracked. We'll see a little diagram on to help you understand that as well. Git checkout, that will have to do with what these things called branches are, and that's another thing we'll talk about a little later, but basically allows you to switch between different branches in your repository. So here's a little infograph of the Git file status and how they kind of intermingle. The files that you start with are all going to be considered untracked, and then when you do git add, say you do git add on a particular file, that adds the file into the staging area, and that file status becomes staged. So once you have that, you can do git commit, and then so all the files that are having the status of staged, that they get committed, which means that they get stored into your quote unquote like long-term memory, and then your status of those files changes into unmodified. And if you modify an unmodified file, it'll become status modified. So these are all tracked from there on out. You can remove a file. So you can say, I don't want to track it anymore. Or you can just delete the file. And so obviously a deleted file will become untracked as well. And you can do the same thing to get a modified file into the staging area as an untracked file, which is just doing a git add. So the remote repository, so GitHub, which is the popular website and the one that we'll have the demo for, has these Git commands that you can use to interact with it. So Git Clone, that basically takes a remote repository, makes a copy of it onto your local computer. So Git pull gets the most recent version of the files from that remote repository and pulls them into your local repository. And Git push takes the most recent version of the files on your local repository and pushes them to the remote repository. So here's a little graph diagram that's kind of helps you visualize this. So above here we have our remote repository. In this case, would be GitHub, and then we have our local repositories, and you can see that many local repositories can be linked to a single remote repository, and so we can have 3 different people working on 3 different machines and have 3 different local repositories, and they will all be pushing and pulling to the same remote repository. So that can be very powerful, but also can be sometimes run into issues, which we'll talk about here in a second. So some like advanced techniques that you are not going to necessarily need unless you're working with other people and in groups, we'll talk about. So Git branching, that's a technique where you basically branch off what I consider, like, if you think about your Git history as like a timeline, it's basically like working with another timeline. So like an alternate dimension. When you do a Git branch, you can create a branch from that original timeline. Well, it's usually it's called the master branch or main branch. And then you can make changes onto that branch without affecting anything in the master. So, and then once you are ready to combine them again, then you can do what we'll see as a merge. And sometimes that will cause issues if there's like conflicts. So just kind of a little visualization here. If you consider all these like nodes, different commits, remember like your commit is your long-term memory. So C0 is like the first time I committed onto this repository. And so like that's the first iteration of the files. And then the second commit here, C1, is the second time I committed. So that's the second version of the files. And then it's just all the way up to the most recent one, which is C4. The most recent version of your files is also sometimes called the head. So the head commit. Master here is just denoting that this is the master branch. So when you do git branch, you can specify the branch name. So here I'm doing git branch fixing AI heuristics. And so what that is if I did git branch from, say, when the master was only a C1, I do git branch, I make a commit onto my branch, which creates C2, and then I do a commit onto my branch again, which creates C4. And then in parallel, someone else could be still making commits onto master. So they get C3 and then C5. So at this point, there's two different timelines with two different, I guess you would say, realities. So to combine these, we would do what's called merge. So merging branches incorporates changes from one branch into the other. And we can use this to work on many different features or bugs at the same time. So in the real world, in your workplace, you might have one developer working on one version of your code and wanting to implement some, feature, and then another developer is going to be working on, say, like unit tests for a different part of the code, and then they can combine those into the master when they're finished with those features. So example of that now, well, this is example of the other way around. So sometimes you want to actually have whatever's going on in master, you want to kind of like update your own branch, because like I said before, people could be still what you call pushing to master and making changes to master that you might find useful in your own branch. So this works both ways though. So in this case, if I want to create pull the changes from master into my branch, my fixing AI heuristics branch, you would do git merge master. And what's hard to illustrate here is that this command is done while you're working on your fixing AI heuristics branch. And it'll make a little more sense in the demo, but if you remember from the git checkout, so you can have a branch checked out. So you're on one branch or the other. So at this point, I would have had git checked out fixing AI heuristics. And then from there, I could say git merge master, because I'm saying I want to merge the master branch into this branch. So sometimes when you merge two branches, you might have a merge conflict. And that can happen when you have the same piece of code or the same part of the file modified by two different people. So it has like two different changes that Git wants to combine, but it doesn't really know which one you want to keep. So it's not going to make that decision for you. So it'll give you this notification that there's a merge conflict, and then it'll have little annotations on where this conflict is. So it'll say like branch has this version, branch AI has this version, branch master has this version. Which version do you want? And we'll show you a little example of that. So it should become a little more clear again with the demo. So that's just kind of the basic commands to incorporate most of the main functionality of Git. There are a lot of more commands that you can do, but these commands are kind of getting into the nitty gritty. So like git log, that will show all the commits, all the commit histories. And git rebase, that's just another way of merging. It's a little bit more tricky. And there's some pros and cons for using git merge versus git rebase. But we won't really go into those details here. But those things you can obviously find out in the documentation. I'll have links at the end to learn more. So the pull request, that's a request for code owners to pull the code that you wrote into the main repository. So with the, hopefully it's a completed feature that you're asking for a pull request on. And oftentimes when you do have a repository that you want to make changes to or improve on, and you want to submit a pull request, they will have some kind of contributing documentation. They'll say, if it's like a free and open source software, they'll have a little README that says, okay, here are the rules for making pull requests. This is what we expect your pull request to be. And these are like what we would like to see syntactically, and some other possible like one-off rules. So after you make a pull request, then that pull request will go into code review. So the owners of that repository will look at your code and your pull request and determine whether or not it's good enough to merge. They can add comments to it, and then you can update your pull request as well. So some little tips on how to get good. So most important thing is practice, and you're going to run into little issues that's it's not always going to be easy to foresee, and you just can't read some documentation and then completely become a pro at it. You just have to really practice. And some of the ways I think are useful are using Git for your homeworks and your projects. So that is like kind of a multi-purpose benefit, because not only are you not having to worry about screwing up your project so badly that you can't, you have to start from scratch, because you can always just go back to previous versions of your Git repository. And you can also use your projects and code in your courses to showcase that in your GitHub repository. So you can demonstrate that for resume purposes, or whatever else you want to decide to use. So the other thing that you can do is try to encourage it into your workplace. So if you're doing any type of coding, this is not even just a coding exclusive technology, but if you're doing coding, then you should be using some kind of version control system. And so Git is by far the most popular. So hopefully that is already being incorporated, but if not, you should hopefully try to see if you can get that incorporated. And the other thing is using what you would call a Git aware editor. So a Git aware editor is just an editor that realizes that you have Git installed in your system, and this folder that you're currently in is a Git repository. So it'll have all these nice little features that will help you work with Git and your files, and also help you prevent mistakes. So my favorite editor for that, and actually my favorite editor overall, is VS Code. And I think that's probably one of the best editors, especially since in this case it is Git aware. There's a lot of editors that are Git aware as well, and so editors, IDEs. But that would be my recommendation. So here's some references and resources that you can look at. I find this guide that UC Berkeley has for one of their courses to be extremely helpful. This guide's I would almost say it's comprehensive. It pretty much shows you almost everything you need to know, including some of those commands that I didn't actually explicitly go over. And there's some nice written narrative. The Git documentation, so the official Git documentation is obviously a good reference. And then of course the GitHub documentation itself. And don't ever be afraid to Google things. So if you have a little error, you're not really sure what's going on, Google these things all the time. Is actually a very important part of the real world skill set. So learning how to proficiently Google and look up things is one of the most important skills of any type of programming job. So setting up Git on your computer. So first thing you do is you have to install the Git software. And there's different ways of doing it depending on what your operating system is. So in Linux, which is the operating system I use most often, it's just a simple command onto your terminal. Mac and Windows, I believe, both have like download packages that you do. You just install it like a software. So you can just navigate to the appropriate websites on those, and it's pretty foolproof in terms of installing it. And then once you have it installed on your computer, then you configure your identity. So this is like how Git tracks who is doing these changes. And it's also going to help track and link your changes from your local repository to your remote repository for things like authentication and whatnot. So you'll first do git config, set a global username, and then git config, set a global user email. And then we'll kind of assume that your Git is already set up, and we'll go ahead and start the demo here. Okay, so hopefully you guys can see my terminal, my shell. So first thing we'll do is we'll just make a directory. And for those that are not familiar with this terminal or the shell, if you're mainly a Windows user, I would highly encourage you to learn how to use what you would call the Git bash or the bash terminal. And in Windows, I think there is a software you can download called Git bash, which is basically like a Linux-like terminal, which uses these what you would call bash commands. So like ls, which is showing you what the content of the local folder that you're currently in is. And then I showed you how to make a directory in these. But these are things that you'll want to learn for a lot of reasons, because one, if you're working with servers, you're going to have to most likely be working with a server that's running Linux, and those shells use this bash syntax or bash-like syntax. So with that, I'm currently in this folder that I just made, this Git demo folder, and I'm going to go ahead and make it into a repository. So we'll do git init, and now we can see that this is now a repository. And so for my little shell here, I have this. You're probably not going to have this on yours. This is like configurations that are customized in mine, but this is hopefully absolutely also going to help you visualize what's going on here as we move between branches. So right now it starts out as in the master branch, and we have no files in our repository. So we have nothing. And now say we want to, we'll have like our initial commit, what we'll call it. So we need to make a file. So I'm just going to make a file of fruits, we'll say. And so now I have this fruits file, and now I can add this fruits file. Okay, and that's in the staging area. You can see here, new file, fruits. And now I want to commit this file into my repo's memory. Because right now, if I didn't do anything else, it wouldn't actually remember this change. So what you do is you'll do the git commit command. And with the git commit, you always want to pass in a message. So you'll do -m to specify your message. And usually you want to have a short message that's descriptive. This case is very simple, so we could just say, and oftentimes when you first commit, the very first commit of a new repository, conventional ways, you just say use a initial commit message. So now this repository actually has any memory to talk about, because without commits, it has no memory. So now it has its first actual memory. And when we do git status, we see nothing, because as far as it's concerned, things that there are no changes, because it already has this memory from the previous commit, and we haven't done anything different since then. So there are no changes, so there's nothing to keep track of. So now if I make changes again, we'll go say, just make these plural. So now we have our modified, and now I have not added it yet. So you see here, it's color coded. Red means it hasn't been staged yet. So I can stage that like before. And now it's ready. It's green, so that means it's ready to be committed into memory. So then when we run that git commit, it will commit that change into memory. Okay, so now I'll just show you real quick the git log. So this is the git log that I was referring to before. This is my initial commit here, and then this is the one I just did. And then this will show for every single commit that's ever been done on this repository by anyone. So here it shows that I'm the person that committed it. I committed it at this time, and this is called the commit hash, which basically is like a unique reference to this particular commit. So that way you can reference that commit if you want to revert back into previous versions. Okay, so next we can do, we can make a branch. So we'll say git branch. Okay, we'll make a chef branch. And let's see, we'll want to check out that branch. Okay, now we're on the chef branch, and say we want to add like a recipe. So I'm just gonna make up some 1 cup of apples. Say okay, and now we can do the same thing. We can add that for staging, and now we can commit that. So here we have, again, it will just be nothing, but we have 2 files here in our branch chef. Now, go back to master, we only have the fruits file, because as far as master is concerned, its memory is the only memory it has is based on what the commit was. And we didn't commit anything that involved a recipe onto master. We've only done that in the chef branch. So we can combine the two. And now we actually have the fruits and the recipe files in our master branch. So this can go both ways. So like I was showing on the slides, you could have done if you were in the chef branch. then you could have done git merge master, and then that would have transformed changes from master, or it would have pulled changes from master into chef. But since chef is ahead of master in that sense, it wouldn't have really done anything. So here, since they actually are the same, it doesn't do anything. So yeah, that's an example here. So I'm going to show a little bit real quick on what happens if you modify the same thing in two different branches and then try to merge them. So let's see if we can create our own merge conflict. And I think we will we'll say like, we'll have some weird typo in here, and we'll first want to add that change. Then say someone else is working on master. Since I'm just one person, I'll have to, go ahead and switch over real quick to do this myself. And say we want to say, oh, I don't want to have any S's in my apple, just one apple. And we can go ahead and create that in memory. And now when we go and try to merge these, we'll see this merge conflict, because in master it says it's trying to say I want the change to be no S, and then in chef you're trying to have git say I want the change to have many S's. So the way to solve that, actually it's very easy to solve when it's just a simple thing like this, but they can be pretty complicated. So you obviously want to avoid, having too many conflicts. So you want to merge things in chunks that are not too often, but often enough to where you don't have one giant merge at the end and then you have a bunch of conflicts. So I'm going to just open up my VS Code editor, and this is the quote unquote Git aware editor. Let's see, I should be able to pull it up here. And so VS Code has this nice interface which kind of helps you visualize what's going on with this merge conflict. So in this case here it says head, which is the current branch's most recent change, and which is of course the one we just did, removing the S. And then this one here is the change that the incoming branch chef wants to make to Apple. So on the current branch, it says, I want to make the change to be no S's. This one says, I want to make the change to be many S's. And then you have to decide which one do you actually want to change. So I'm going to decide that I don't like typos. So I can just click accept the current change. So now I've merged the two branches, and I'll just save that. We have to actually make this official by committing this change now. Okay, so don't worry about this here. This is just a little configuration file that's, you can do some like other things with these commits that make things a little more automated and fancy. So don't worry about this part here. But yeah, once you do that, then you've successfully resolved your merge conflict. And now these two branches are up to date and synced. So I think we can move on to the GitHub part. And like I said, the GitHub is just really a remote repository. And the Git technology is the underpinning of this entire interaction. And so in order to start with that, we can navigate to the GitHub website here, which I'm already here. I'm already logged in. Now you can just make up your own GitHub account. and you'll have like a landing page. It'll just ask you to, for an email address. It's just a simple sign up. Then once you have that, you'll have this landing page here, and you can click on this new repository button. And here you will specify the repository name, and you can write a little description if you want. And actually probably don't need quotes. So there's two settings. You can have public or private. GitHub, I think, might charge for privates, or you'll have a limited number of private repos you can maintain. But I think with certain versions, you can get like almost unlimited. Like there's like student versions, and but as a rule, I think there might be a limited number of private repos that you can actually have. But don't worry about that. We're just going to use this regular public-facing repo. And here are like some standard files that you might want to automatically add to any repo that you commit or that you create. So there's a README file, which you might, if you guys have seen any GitHub repos before, they should all have a README to describe like what the project is about, anything that the user or contributors need to know about this repository. And then the GitHub website will just help you make this automatically. It just adds a little file and some like default text. Git.ignore. So this is a hidden file that you can create into your repository, which just lists files in your repository that you want the Git technology to ignore. So sometimes you'll have like these, like if you're using Python, you'll have like these files like PyCache files that you don't really want to update those or commit those or put those into your remote repository. They're just cache files. So you might add that into your git.ignore. And if you're on your Mac, there are oftentimes these .ds_ignore files, which I'm using the Mac right now, but that's something that's, it can be a nuisance sometimes if you are using GitHub or Git repositories and you're always finding these .ds store files. You put that in your git ignore and it'll completely ignore those. So we just have a little default git ignore, and GitHub has some like standard files that it might throw in there for you for like a given language. So like say this is a GitHub repository for a Python program. And so I can just say, just give me something that will get me started for Python. So it might put in there like, ignore the PyCache files, for example. And then here's a license. So this is completely optional. It depends if you want to have a license or, if you even know how those work. And that's, something that you can choose to do. And then now we can go ahead and actually create the repository. And now here we actually have our official remote repository. Now, this remote repository only exists on GitHub. I want to actually have this remote repository on my local computer so I can make changes on it on my local computer. And in order to do that, you can do it a few ways, but the standard way that you should do it is using this clone method, which we showed a little bit on the slide presentation. You can download this repository as a zip, but that doesn't really link this remote repository in a way that you can make changes and then push it. You can adjust that later, but it doesn't really download it as a actual repository. So here, when you do Git Clone, you can do it through, this is a new feature, which is something I haven't played with, but through HTTPS or SSH. And I'm just going to copy this. So that's the whole link URL here, just copy. And where's that terminal? Now, when I use the git clone command, I can paste the URL for this remote repository that I want to clone. And now Git will fetch it from that remote repository. And for this, you do need an internet connection. So it'll go to GitHub, say, give me this repository. Okay, great. Now I have our actual GitHub repository. And you see here, the default is master on my Git demo repository, but this one's main. They're the same thing. So this is something that GitHub recently changed, I believe. They had their default branch name switched from master to main. And from here, we can do all the same things as we did before. Let's see. So let's say we want to add something to the README. And we want to add that change so that way we can make a update to the remote repository. So usually when you make changes, it's good practice to actually just do that on a branch. So here's a little shortcut you can do. This is going to make a branch and check it out at the same time. So I'm going to name a branch update README, and then it makes it and checks it out. So here, since I made that change before I created that branch, it does actually incorporate that change into the branch. So in order to make that change now and merge it into the repository on the remote repository, we will use the git push command. And we want to, okay, let's see. All right, what do I do here? So README does not appear, view Git repository. No, of course not. I think I might have messed up a little bit with this when I checked out after making that change. Let's just do this. Okay, so now we're on a branch here, and say we want to add some fruits. So we're going to have to set the origin for this, which means oops, yeah. So yeah, I accidentally That's what I was missing. So usually I just do the -u as like a little shortcut. So what this is -u's just saying that the upstream, which is basically where I want this push to go, is origin, and origin by default is whatever the repository that you cloned is. So it's saying, let's see, where's mine? Oh, I was just gonna use this. So upstream origin says that GitHub repository from GitHub. So this link here is what origin is. And then the second part here is the branch that you want to push onto that repository. And here you can see that GitHub recognizes that you push to this repository, and now it's asking if you want to create a pull request. So here is the button for creating a pull request, and you can go ahead and click on that. And here we'll have like some comments. So let's say it's like a list of fruits. And here's a little title. These things are things you want to think carefully about, and depending on what your contribution README says, or if there's any rules for that repository you're trying to create a pull request on, you want to follow those guidelines. But here's a very simple example. We can see here that this was the change that we made, and since this file didn't exist before, there's nothing on the left here to compare to. So here it's just on the right, some visualization that says I added these 3 lines. So if there's a line that was existing on the left side before and I removed it, you would see like a minus, and it would be highlighted red on the right side. So it was just to indicate that you removed this line and then you added these 3 lines. Once you have that filled out, you can click that green button to actually create the pull request. Now, this actually officially created the pull request, and whoever owns this repo, which in case I do, can look at this, and they can look at your files, and they can look at the changes that you're proposing. And this is just the history of the commits. We only made 1. And they can determine whether or not they want to incorporate those changes into their main branch. So or whatever the branch is that you're trying to push into. So in here, we're just by default, it's the main. So main from new branch. And we can make some comments here. So I can write down here. Or I can just say, so I can add that comment in, and then this will give a notification to the person that made this pull request saying, you can see the comments, oh, you need more fruits. Then we can make changes onto that by making more fruits. And I want to leave some time for questions here, so I don't want to go too much more on this. But now say like I wanted these changes and I accept them as a code owner, I can just say merge this pull request, and I'll confirm the merge. And now when I go back to the actual repo here, my file has been added and the changes have been incorporated. Here's a little time on how long ago that pull request was incorporated, or that pull request was initiated. And yeah, so yeah, we got 10 minutes, I think, but I could stay a little longer if we have more questions, but want to go ahead and open it up for questions at this time.
Thank you, Matt. I believe that there is already a question from a student in regards to a fruit file.
Okay, yeah. Yeah, go ahead and, I can't see any in the chat, so if someone's typing in the chat, I don't think I
can read it. Is the text in the fruit file from chef replace the fruit file in master?
Is the chef in the fruit file, what's the rest of it?
It says, is the text in the fruit file from chef replace the fruit file in master?
It's not like a copy paste, like completely replace. It's the changes. So it only, so Git maintains a memory of the changes. So, and that's for like efficiency purposes. So if I didn't make a change to pairs, for example, say like master, say the file in master is fruits, and then it's apple, oranges, pears, and then in chef it's apple, oranges, pear with no S, and then I merge the two. So if I merge chef into master, since pairs is the only difference, that's the only thing that's going to change. So it will only change that line pairs. It won't do anything to the other lines because there was no changes. Um, so hopefully that answers your question. And there is a direction to merging. So you can merge in either direction. And so the changes from the merge goes from left to right. So merge from chef into master, which means that the changes in chef will be applied to master, not the other way around.
Great. He said thank you. He got it.
Awesome. Great. Let's see. Oh, maybe I can see. Okay. Okay. It looks like I can see some chats. Let's see. Will the PowerPoint presentation be available? I can make it available, but this is recording. This presentation is also being recorded. So yeah. Okay. You got that. Let's see what else. Is it possible to use different branches, A to B, two different implementations, same feature? I think, yeah, it's definitely possible. But whether or not you want to have two different implementations of the same feature, I mean, you could do that, but ultimately, if you want to use like your master branch as like the single source of truth, and like that will be the branch that you use for like say like your production, or you're going to use that to make your software based on that branch, based on the master or the main, which is most commonly what people do, then only one of those changes is going to ever be incorporated into the master branch. But you could have just two parallel versions where one is implemented differently than the other, and you can have two versions of your product if you wanted, and that's perfectly fine. But whether that's good practice or not, I maybe there's some cases for that, but normally you have like one source of truth, and like that's your main or master branch. I think I got that safe. Okay, great. Okay, any other questions? Like I said, I can stay a little longer if there's anything that's
Questions. I do want to announce another event we're having this week. Our data science student group is also opening this up to the computer science students on this call today. On April 16th, from 6 p.m. to 7 p.m., there's going to be a skills workshop. They're going to be teaching Python Tableau, and I'm going to actually drop the link. It's an Eventbrite invitation, so if you all want to RSVP for that, here's a link. Great. And there's another question for you too, Matt.
Oh yeah. Okay, let's see. So if one needs to change user name on GitHub, what kind of problem you run into? If you want to change your username on GitHub, I'm not like actually on GitHub. I haven't actually tried to do that. I don't know if you can. You might need to make a whole new GitHub account if you want a different username. Let's see. So it'd probably be like under settings, my name. So, okay. So it looks like it's pretty easy to change. What problems could that arise into? It's probably, it might be confusing for some people, but GitHub will have like links to your repository or your GitHub profile, whatever it is, regardless of what your name is. So I can make a change. Let's see. So like here I'm working for work, and these are all open source, so it's no problem for you guys seeing these things. But if let's see. We just look at this. So So this person here is, this is their name's Banam B. And if they change this to be something else like Banam C, it will show Banam C, but if I want to see their profile, I can still click and find their profile, and it'll still be linked to like the same person. But then if the name's different, it's not really going to matter. So hopefully that answers that question.
Great, and we have about another 4 minutes, everyone, until we end the event. So feel free to keep asking your questions to Matt in the chat, and we'll stay on for about another, actually now 3 minutes.
Let's see, maybe I can well, let's see, maybe one more thing I can bring up. Again, like I'm just going to open up for questions. So it's a little side thing here. If I wanted to revert back to a different version, so if you remember, here are different commit history. So this is a different versions of my code. I can cherry picking. That's pretty like that's not really something that you're going to probably. I've never used that. Let's put it that way. Git has a lot of different functionalities that you can do. That it's just there to provide power if you need it, but that's something I've never used before. So I'm not even really sure what the use case for cherry picking would be. But yeah, like I was saying on the presentation, there's that Berkeley's GitHub tutorial, I guess you would call it, and I think they have a description on what cherry picking is, and they have a description on like a lot of these other commands. But what I was going to mention here was if I want to get reset that, and then I pass in like a hard so git reset head. So that just means, if I made changes and I didn't commit anything, it just goes back to whatever the actual commit that I did make was. And I can do that for any other. Head is just like the name given to the most recent one, but you can use the actual, I guess didn't commit this. Yeah, it's on the slides. So let's see, I can copy and paste it into the chat so it's like easier to access rather than like the video here. Okay, so yeah. Yeah, that's always been a good reference for me. And of course, the actual official documentation, which was even more detailed, that you can always reference and are on the slides as well.
Great, Matt. Thank you so much. It is 3 o'clock and we want to be mindful of your time. We really appreciate you speaking with everyone. And if anyone wants the recording of this, please email me. Also, I really encourage everyone who's interested in doing a similar event such as this, viewing a similar event, but with Python this week with our data science student group. I did drop that Eventbrite link in the chat, but feel free again to email me. I will include my email at the end of this. So any further questions you have about this or any feedback, please feel free to contact me at any time. And I'm going to drop this link right here or my email. And again, thank you all very much. Thank you so much, Matt. I hope you have a great rest of your week. And I hope everyone has a great week as well.
It was my pleasure. Thank you guys for coming.
Thank you.